Okay, critical thinking, interpreting histograms. We want to explore the data by analyzing the histogram to see what can be learned about CVDOT. Now, C stands for the center of the data. V is the variation of how the data is spread. We want to know what the shape of the D, which is the distribution, determine whether there are any O for outliers, and T for time. So here's common distribution shapes. Here you can see that we have our frequency. This is a bell-shaped distribution. Over here to your right, this is a uniform distribution. Over here, we have a distribution that is skewed right because you can see the tail is going to the right. And over here, we have a distribution where the tail is skewing towards the left. Okay, now, in a normal distribution, when graphed, a normal distribution has a bell shape, as shown with the figure to the right. The characteristics of the bell shape are, one, that the frequencies increase to a maximum and then decrease, and two, symmetry, with the left half of the graph roughly a mirror image of the right half. Many statistical methods require that sample data come from a population having a distribution that is approximately a normal distribution, and we can often use a histogram to determine whether the requirement is satisfied. So here you can see, here's your histogram, and if you draw a bell shape, and it looks like approximately a bell shape, therefore we know that that represents a normal distribution. Okay, now a uniform distribution. Now with data having a uniform distribution, the different values occur with approximately the same frequency. So the heights of the bars in the histogram are approximately uniform as seen on the right. This isn't data that we would like to use when we're testing a hypothesis, but we do need to understand that if we got a histogram like this, this would be something that would cause for us to have concern by proceeding with the hypothesis testing. Again, this is considered a uniform distribution. Then we have skewness. Okay, now skewness is a distribution of data is skewed if it is not symmetric and it extends more to one side than to the other. So, skewed right. Data skewed to the right, positively skewed, have a longer right tail. So again, when you see here, this tail skews to the right, so it gets smaller and smaller, and it's longer on that side. So therefore, it's a skewed to the right distribution. And over here, we have data where it's skewed to the left, or a negative skewed, to have a longer left tail. So therefore, you can see there's a longer left tail over here that would make that skewed left. Now, assessing normality with normal quantile plots. Now, some really important methods presented later on in the course have a requirement that sample data must be from a population having a normal distribution. Histograms can be helpful in determining whether the normality requirement is satisfied, but they are not very helpful with small data sets. Now, the criteria for assessing normality with a normal quantile plot. Well, it's got a normal distribution. The pattern of the points in the normal quantile plot is reasonably close to a straight line, and the points do not show some systematic pattern that is not a straight line. Now, for not a normal distribution, the population distribution is not normal if the normal quantile plot has either or both of these two conditions. The points do not lie reasonably close to a straight line pattern, and the points show some systematic pattern that is not a straight line. So the following are examples of normal quantile plots. Now, to your right over here, this is a normal distribution. The points are reasonably close to a straight line pattern, and there is no other systematic pattern that is not a straight line pattern. Now, this one over here, this is not a normal distribution. The points do not lie reasonably close to a straight line. You can see all the points are kind of over here, and there's some points over here and here. So all these points are not representing a possible straight line pattern. Therefore, this is not a normal distribution. Over here, you can also see that this represents not a normal distribution. And the reason why is that the points show a systematic pattern that is not a straight line. Now, this pattern shows this kind of curve that's going that way, and therefore it's systematic, but it's not showing a straight line pattern.